Okay, about that rotation, I just want it to be clear why the rotation is what it is. This triangle up here. Now I tried to do it here and I kind of made that ugly. So I redid it. I doubled the size here. It takes 8 squares to make an inch now on this page. So what we have here is, if you look right here, you see that red line that I'm following along. That's a tool path. And you can see how far off it is from being aligned with the x-axis. Okay, so that's what the rotation is. 4.18 degrees, but there's the whole number there. Okay, I just want to make sure we're clear on why the rotation is what it is. So now we know, and I did some more work up here off camera. This is based on information we already have. We know this angle, 6.7 degrees, but again, there's the whole number. Okay, so we know the length from the origin here all the way out to there, and we know this radius, and that was 2.125 inches, and we know this angle. So now with this one, we're going to rotate counterclockwise to align this tool path from there to there. We're going to rotate counterclockwise to align that with the x-axis. So we know that this hypotenuse here is already at 6.7 degrees, and we're going to add that to it. And when we do, the center of that cutter location and the center of that will be, they will be both at the same y distance from 0 y. Okay. Now this right here, I got this number from, these are numbers that we already have. We know that the center of this spoke between these two cutters here is 0 degrees. And then I drew 2 cutters up here. And we know that the center of this spoke, that's not completely drawn, but that would be the center spoke. We know that that's at 72 degrees. So since we know that from 0 degrees we went 6.7 degrees, and then you would do the same here. From 72 degrees you'd come back towards 0, 6.7 degrees. So you just take the 6.7 degrees, multiply by 2, and you subtract that from the 72 degrees, and that's what you get. And now what that is, this is a tool path right here. You would plunge in here, and so basically you would go, you could make this radius cut right now, that tool path. You could take your cutter, it's at 0, 0, and you can go in X, you would go out to all the numbers that we have. You could go out to here, which is, there it is, 2.11 X, and then so you came out to here, and then you go up to 0.25 Y, and your cutter would be right here, and you would leave your cutter there and rotate the rotary table 58.48 degrees. Now you can do that right now, and that might be less confusing, but it's one extra place you're going to have to go to, because you can make that radius cut after we've done the rotation to make this cut. So now I have up here, I just redrew the same the cutter positions, those four right there are redrawn up here. Okay, so we know what angle this radius is already on, and we add that to our rotation to that, and that's going to swing this up. And we also know what angle this orange one is on. There it is right there. It's 36 degrees. And again, we add our 4.18 degree rotation to that, and it'll swing up, and you'll see that they are both in a straight line from each other in X. They're both perfectly horizontal with each other. Alright, so let's do that. We have alright, I have these stored, both of these stored, so it's A. There we go, there's our 6.75 right there, highlighted in blue. And let's add that to the answer plus. I have that stored, I have the rotation stored in R. If I can find it, there we go. Answer plus R. So now that's the longer one I just added. Yeah, A plus R that's this one. So now we know how many degrees it's going to be at after our rotation. 10.939. There we go, 10.93966 degrees. And so we can take, to draw this point, we do the same thing we've been doing. Okay, so we take the, first of all, let's store that so we don't have to keep trying to find it. So let's store that in, let's just put it in B. Okay, now we take the sine of B and multiply that by the radius, which was right there, 2.125. And we get 0.403. Now this is a number you'd write down, and we don't have to write the whole number down anymore, because this is actually where you're going to go to on your mill, on your digital readout or your dials. But I need to draw a point, so I'm going to divide that number by the value of each square is now 0.125, and that'll give me how many squares to count up. So we're going to go 3.226 up. Let me do the cosine also. Okay, the cosine of B times 2.125, and then divide that by 0.125. Okay, what did I do? I got 16. Oh, that's actually that's not. I forgot it. I doubled the size here. So that's like more than 16 and a half. Let's do the 3.2 squares up first. Okay, so from here, this is the line that's 0. So we're going to go up 3.2 squares. So 1, 2, 3.2, something like that. And for our cosine, I already know that this is 17, so 16.69. So that would be 16, a little bit more than half. So we're going to come back here. Now that's the new center of our cutter. So we're going to draw the cutter again here and write that number down. And notice that number, that distance in y is 0.403. 0.403. Now watch when we do the other one. It'll be the same number. Okay, so now this time we're going to take 36 degrees plus our rotation that was in R. 36 degrees plus R. Okay, that's where that hypotenuse will be. And let's store that. Store that in C. Okay, now sine C times that shorter radius, the orange one, was right there, 0.625. See that number's the same? 0.403. That's our Y location. Let's go up and find it. There it is, right, I passed it, right there, 0.40327. 0.40327. It's the same number. So our distance in Y is the same, and we can make our cut in X. We're going to set the Y axis. We're going to go to that location in Y, and one of the two locations in X, and we're going to plunge in, and we're going to cut to the other location in X, leaving the Y alone while we're cutting. So there you have it. To draw that point, oops, okay, divided by 0.125. Oh, okay. All right, I'm going to do this off camera, and then you'll see everything rotated. I'm going to draw like I did there. I'm going to draw this one moved up a little bit, and both of these are going to be the same numbers, but opposite sign. Opposite sign in Y. Okay. Okay, we only had one more to do, and then the plans are, all the numbers are pretty much done. We left off at the sign of this one right here. We got the height, and we just got to do the cosine. So this hypotenuse here that's orange, that's already at 36 degrees. We're going to add our rotation to that. So we get 36 degrees. Oh, wait a minute. We don't have to do it that way. We can do, we can just go right into it. The cosine of 36 plus our rotation. Alright. Times that radius was 0.625. And that's our distance in X, 0.477 for this guy right here. Right there, you see I have the number. So looks like this is where you would plunge. There's your two numbers, 0.403 Y, 0.477 X. Plunge in there, lock the Y-axis, and cut. There's the tool path. There's the tool path right there. And then you stop when you get to 2.086. Yeah, I'm going to hover over these numbers so you can write them down. That's going to be the same. Yeah, that's the same X, exactly the same X right there. That point and that point. And there's the Y for those. And that's the Y for both of these. Negative 0.40327. And up there is 0.40327. These are the actual numbers now. We're going to use all the other numbers where all of these were temporary. We had to get these numbers unless you wanted to make that radius cut while your rotary table was set to 0 degrees. Then you would use some of these numbers, but I'm not going to do that. I'm just going to make this rotation here, and okay, basically it's time to, we can start writing the plans. This is what I did here. You start directions. All those pages so far were to have numbers, so we can put numbers on the instructions here. So see right at the top here, cutters at 0x 0y, rotary tables at 0 degrees. Step 1, rotate 4.18 degrees. Now for me that's 125.5 ticks on my rotary table. It's not even a whole turn. Step 2, go to, there's your X and Y. X comma Y. Yeah, that's a comma and that's a point. Okay. So you're going to go to X comma Y or subdatum 1. I like to use subdatums because I make so many mistakes. Lock the Y-axis. Plunge. Cut to that location in X, or that distance in X, or subdatum 2. Lock the X-axis. Step 3, make the radius cut. Rotate 58.48 degrees more while cutting. Now for me, I have a whole list of how many turns and how many ticks that is on my rotary table. So you see there it says the second one here, the second line here. Rotation plus the radius cut would be 62.67 degrees, and that's equal to 12 turns and 80.12 ticks on my rotary table. So I have all of these here. I have all the circled in purple. That's where I cut to in the radius. When I do the radius cut, that's where I stop. Anyway, maybe I should provide a how to set your rotary table. I'll make that a separate video. So, yeah, let me hover over the rest of this so you can get the idea. Make the radius cut. Yeah, okay, we did that. Okay, step 4, go to the next reference angle and repeat 1 through 4 for every reference angle. So that means go to 72 degrees. That would be the center of the spoke. That's the next reference angle. That's what I call it. Then, so you went to 72 degrees, but then because you're going to repeat 1 through 4, you go up to 1 and you're going to rotate 4.18 degrees past 72 degrees. And then you just you repeat all these steps for every repeat 1 through 4 for every reference angle. And then down here we have step 5, rotate negative 4.18 degrees. That's from 0. Put the rotary table back at 0. I mean, it doesn't matter if you do that. Just to be less confusing, if you put the rotary table back at 0 and go negative 4.18 degrees this time. And yeah, I put that negative 125.5 ticks. Go to 2.086 comma negative 0.403. That's again x, y in that order. So that's a location in x and y. Or subdatum 3. Lock y-axis, plunge, cut to that distance in x, or subdatum 4. Step 7, go to the next reference angle, repeat 5 through 7 for every reference angle. The radius, the second paragraph is shorter because the radius cut is already done. So that's the idea. Now it's time to get on the mill. I can't wait.